Hello and welcome to the third video in this series where I create a web browser from scratch in Swift. Now at the end of the last video, this is where we got to. We've got a very simple app which loads up this HTML file and just displays it as is in a window. Today we're going to actually start parsing this HTML, and the first part of parsing is tokenization. So we're going to split up the HTML file into tokens. So the HTML open tag is one token, the body open tag is another token. We'll have a token for each of the characters, and each of these end tags will be a token as well. At the moment we're displaying the data string, which is empty there, but then we load up the data string with HTML from the file here. So instead of that, let's temporarily load that string up, but then get the data value by creating a parser and then asking it to parse that HTML. And the parser is going to hold on to the HTML. I've got an initializer that just sets that. We've got a function that does the parsing. Oops. And for now, what we're going to do is return a string from the parser that describes what the tokens are. So let's make that string. And as I said, the first step in parsing is tokenizing. So what we want to do is create a tokenizer. Give the tokenizer the HTML. In fact, let's do a repeat there. What's the token that we get is not an end of file. I'm going to get a token, and then whatever is returned, we're going to add that onto our data string, and what we want to return is data. We need to declare that token. So HTML token. So a HTML token, it has a token type. So what tokens do we have? We have a start tag. We have an end tag. We have a character. And we'll also have an end of file. If it's a character token, then we need to store what the actual character is. But we'll have that as an optional because it might not be a character token. It could be a start tag or an end tag, and in which case we'll store the name, which will be an optional string. So we'll initialize those values. But for the name, I don't want to initialize with a specific string. I always want to initialize it with an empty string. So we need a textual description of what the character is, so that we can, you know, we're going to display it on the screen, what the tokens are. The standard way of doing that with Swift is to create a description variable, which is it's a calculated variable rather than a stored one. To make that work, we need to make this struct of type custom string convertible, depending on the type. So we need the actual tokenizer now, don't we? The process that we need to go through for a tokenizer is specified. The entire algorithm is specified in the web standards. So we've got this is the online spec, the living spec they call it. This is the current standard for HTML, and this is the part about tokenization, and it says that the algorithm is a state machine, and it starts in the data state. So let's do that. Has a state, it starts in the data state. So we'll initialize the string, and as we're going through the HTML data one character at a time, we need to index that character. We need to know what the current character is that we're on. So I'll have another variable for that. And the type of that will be a string index. If you're dealing with ASCII strings, then you can index into them with just an integer. It's an array of bytes. But with Unicode, it's stored in UTF-8 form, and so you can't just deal with that as an array of bytes. So instead, what Swift does is it has this type called a string index, which points at a particular character in a string. So that's what we need to use. So we'll initialize that, and we'll initialize it to the string and the first character of the string. And then we have a function to get a token. We need to have a loop, get the first character and the subsequent characters at the start of that loop. So let's have a function to get the character. What I want to do is check that current is within the string and not at the end of the string already. Otherwise, let's get the character. And once we've got the character, we want to move the pointer for the current onto the next character, ready for next time, and return it. Return the character. Here we're returning nil. Okay, so we've got a character in our loop. the next thing to do is to check whether it's a nil or not. So in the guard we'll check char to see if it's a nil or not. If it's a nil, then it'll do what's in the else clause, and in the else clause what I want to do is to return a HTML token that's of type end of file. What I want to do is switch on the state, and the first state that we know about is the data state. Within the state we want to switch on what the character is, and then we'll look at the we'll have a look at the spec. So here we are, we're switching on the state, and if it's the data state, so that's this, then we'll ignore that. We haven't got any ampersands, we have got a less than sign. So if we do a case for the less than sign, what do we do if there's a less than sign? We switch to the tag open state. Other than that, what do we do? We're not going to get a null. We could get an end of file, but we've already dealt with that up in this guard here. We've dealt with that for all cases. Anything else, emit the current input character as a character token. I'm not sure that we're going to hit that, so let's just put in here are not yet implemented. So if we get here, we'll get a fatal error. So we've not implemented this yet, and then we can implement it. What's going to be useful is if we put in there what the character is that we've just seen. So it said our new state is a tag open state. Well, we don't know about what that is yet, so let's add that one. Switch must be exhaustive. Well, yeah, that's because we haven't put in the case for .tag open yet. And in all these cases, we're going to end up with another switch depending on the character. And again, for the moment, I'm just going to put in a default that says fatal error. So the idea here is that I want to implement the absolute bare minimum in order to tokenize this this HTML, and so I implement the bare minimum, put these stubs on that says not yet implemented on bits that I haven't done, and let's running the application. It'll then tell me what I've yet got to do. Alright, yeah, I've got it. It's token.type. We need there. Let's check that. Okay, not yet implemented, that's what we wanted. So we've gone through the data state, we've picked up the less than sign. That sent us to the tag open state. The tag open state has just given us an error message saying, well, I've got a H now, so what do I want to do? So let's look at the spec. So the tag open state, ASCII alpha, that's what we need there. So I could put in here a range, and same for uppercase, and then deal with that. But I'm going to have to look for letters in pretty much all of the cases, all of the states that it's in, and it's going to be a bit of a pain having to type all that out. So there is a way in Swift to do it that looks a bit nicer. If you do case underscore, that'll match absolutely anything, but then you can add a where clause, and in this case I can check whether C is a letter, which is letter is a built-in function. So that looks a bit nicer. So if we check back with the spec, ASCII alpha, we want to create a new start tag token, set its name to the empty string. Well, the initializer on a start tag token will do that anyway, and then reconsuming the tag name state. So state equals tag name state, which we haven't got yet, so let's add that. A new state called tag name. Not there, there. And as always, we're going to do a switch on the character within that. And again, for now, we'll have a default that does exactly this. Okay. So again, tag open. Well, we've got an alpha. Create a new start tag token. Which I haven't done yet. So I want a token to be a HTML token of type tag. To declare the token up here. Okay, so I've created a start tag token and it'll have an empty name with the initializer on that. We've changed the state to tag name, which it says here, reconsuming the tag name state. Now what reconsume means is we want to keep the same letter, the same character that we've used here in tag open. When we switch to the tag name state, we still want to be on that same character. We don't want a new one. Now the problem is that when we go around the loop, it'll get a new character, and that's not what we want. So instead, what I'm going to do is take that from off the front of the loop and put it in front of the loop. So that'll get a character the first time around. I'll sort of preload the character. Then at the end of the loop, I'll get the next character. And what that enables us to do is, where we have the reconsume, what I can do is continue. If I do continue on a loop, then that means don't do anything in the rest of the loop. Just go back to the start of the loop and start again. And because I've moved the get character out from there, it's not going to move on a character. And just to make that clear where that's going to go, because it's a bit of a go-to, is that what I'll do is I'll label up the loop with reconsume, which means I can then put continue reconsume it down here, and then it very much looks like the spec. Create a new start tag, reconsume the tag name state. That matches very much up with what we've actually written, so that makes it clear. So let's give that a try and see how far we'll get now. So we've reconsumed, and we've got what we wanted. We're still on the H character in here, so we can start dealing with it in this state. So if we look at the spec again, the tag name state, we can ignore the white space stuff for the moment. We can ignore self-closing start tags because we don't have any in our minimal HTML. But what we do have is a greater than sign. At the end of a tag, we have a greater than sign. So we do need to put that in. So in this case, what we need to do is switch the data state and emits the current tag token. So state back to .data, and then we're going to return token. If we look, that's get token, we're returning a token. That's what we're doing. So let's see how that goes. Okay, and once again, it's taken us back to this to say we've not yet implemented what to do if it's a character. So let's do that. If it's a letter, I should say. Again, let's look at the space. So ASCII upper alpha. Append the lowercase version of the current input character to the current token's tag name. So lowercase version of whatever it is. So token.name append C dot uppercase, lowercase it should be, shouldn't it? Lowercase. Tokens are optional. That's the issue there. So hopefully that'll put the character into the name of the tag. Let's see what happens. So not yet implemented. Under data. And there's no character there. What's going on there is that it's probably a new line or a tab, or it's some kind of white space anyway. That's why we can't see what it is. If I look at the information down here, if I look at the token, the character is a new line. That's the reason we can't see it. So what we'll do about that, let's escape C. But that's just a character. I need to convert that to a string first. So see how that does. Okay, so now we've got, it shows us what character we're not dealing with there. And I'm going to do the same on this not yet implemented in the other places that we have that. So in the data state, again, what we're doing, not that, not that, not that, not that. Anything else, emit the current input character as a character token. So I'm going to replace this fatal error with a character token. And the character is going to be C. I think that's right. Let's give that a go. Yep, well, it's skipped on a bit further. Not yet implemented /. So I believe that we've dealt with all of this and we're now down to the / on the closing tag for body. I think that's where we are. But we don't need to guess. It's a tag open state. Tag open state. In the case of a /, what we need to do is switch to the end tag open state. So, case / end tag open state. Let's add that one in. So new state. To switch on C again and have a look what happens in the end tag open state. Here's the end tag open state. The character we're well, what we need to do is look for default, isn't it? Check for the default and report that. Run it again. Sure enough, we've ended up on the not yet implemented. We've got the B, so that means the prediction's right, that we're on, that's where we are on the parsing. Go to the spec, end tag open state. Hit ASCII alpha, create a new end tag token, set its tag name to the empty string, and reconsume in the tag name state. So I've got a case. I've got a case like that. I'm going to create a new token with the end tag data state. We'll change the state to the tag name, and we're going to reconsume. That's exactly it. So let's see what that's done. Okay, so we've got start tag HTML, start tag body, end tag HTML. What we haven't got is any character tokens there. I wonder why. That's because I've not returned the token there. I think that's the only place I return character tokens, so let's give that a try. And there we have it. We've got a start tag, we've got a character. It's going to be a new line there and a tag there, and it's not showing us. So I might deal with that. So we've got start tag, end tag. Everything's there, except it's not showing us the white space characters there. So what I need to do is where I'm displaying the token in here, that needs to be unescaped. I maybe should have written unescape just to do characters rather than strings, but hey ho. See how that does. Okay. Start tag, we've got the characters, body. I'm displaying too many new lines there. Why is that? Because that should be a tab, that's why. So, all of that looks absolutely perfect. Yep. So that's it. That was the target we have for today, to split that up into tokens, and that's what we've got. So I'll call it the end there. Thanks for watching. Do like and subscribe if you want to encourage more of these videos, and please, if you have any questions or any suggestions, then please do comment on the video. Thanks very much for watching. Bye bye.